Hi, everyone. So thank you for joining me here today. What we are going to cover today is going to be a first module in the data engineering course. So the link to the course here is in the description. I'm going to quickly open it. To open it. Yeah, go to site. So this is our data engineering course. So this course is an introduction to data engineering where you're going to learn data engineering for free. It's going to start soon in January. And this course was created 4 years ago or 5 years ago, quite some time ago, right? And some of these things need updating. And in particular, the module number 1, the module with Docker and Terraform. So this is what we are going to do in this session, in this workshop. In this workshop, we are going to go through the entire module number 1. And I'm going to give you an updated version of that. We are going to use new versions. We're going to use new Postgres there. And I know most of the things, most of the problems, most of the places where you had problems when doing the course. So here I'm going to explain how to go around these problems. So I'm going to present an end-to-end working version of this module. And it's going to become the new updated module here. So that's the plan. Two other things. So in addition to the course, the content for the workshop is here. This is the second link. This is what we are going to go through today. And later it will become, I'll put this to the course. But right now, today we are going to use this link to go through the content, and then then we'll move it to the course later. And finally, there is a link to Telegram. So this is where you can subscribe to get updates about the course. The course is starting in January. And right now we are preparing for this course. There are a few other things that might be interesting for you. If you go to DataTalksClub page, you will find, first of all, pre-course Q&A next week on, I think it's Monday, where I'll answer your questions about the course. And then the actual course launch will be on January 12th. You can sign up for both events. So you will find the links if you go to datatalks.club. Okay, now let's get started. So in this module, we are going to talk about Docker. So for that, you need to have Docker installed and you need to have Python installed. So these are the two prerequisites you need to have for that. And also, ideally, you should have a GitHub account. Because in this video, in this workshop, I'm going to use GitHub Codespaces. Because GitHub Codespaces is a remote, it's very convenient remote environment that already has Python and already has Docker. So you don't need to install that. So this is what we recommend using for this course. We recommend using Codespaces. And right now I'm going to show you how we can create a remote Codespace environment. You, of course, can do this everything locally. If you have Linux, it's ideal, right? So installing Docker on Linux, it's quite straightforward. Installing Python is quite straightforward, so you will not have any problems. If you have Windows or macOS, it might be more tricky. So here, especially when it comes to Windows, like every version of Windows is unique and it comes with its own challenges. So if you want to go with that road, fall down that road and do things locally, you will have to figure it out yourself. So we cannot support every single I don't know, kind of setup. So some of you might have Windows Home 10, some of you might have Windows Pro 10, whatever. Like we are not able to support all the different environments. That's why we recommend that you use Codespaces. And I'm going to show you how you can do that. So we are going to create a new repository on GitHub. And I'm going to call it, let's say, data engineering Zoom camp or something like this. So since in this module, we are going to focus on Docker, maybe I'll call it Docker workshop, right? But then for you can give it any name. So let's say if you're doing this for the course, then it makes sense to actually give it data engineering Zoom camp name, right? Workshop, code spaces. And then we need to add README. And for git ignore, I'm going to create a git ignore with Python. Right, so now I create a repository. It should be public. And now my repository is created. And now I click code, and I have this tab code spaces. I don't have any code spaces running, so I click this button, create code space on mine. Yeah, the course is free. This is correct. The course is free. And the question about the link, yes, you will find the link in the description. So I showed at the beginning how to find these links, so you can just go back and check these links again, right? So you can just rewind. Okay, so right now we are starting the remote environment. Actually, you can use it from your browser. It's totally possible. So we have here Docker, we have Python. Okay, hello. We have Python that we can use. I don't recommend using the browser because like it feels a bit limited maybe. I usually use it through Visual Studio Code Desktop. So you will need to install that too. Again, this is optional. You can work from the browser, but I find it more convenient to work from the desktop Visual Studio Code. So which means that for this workshop, you will need Visual Studio Code Desktop, GitHub account, and then the rest you configure remotely through the remote environment. Yeah, I just mentioned the prerequisites. So there will be a session about Q&A session next week. I showed you at the beginning how you find it. So better ask your questions there. So right now, I want to focus more on the workshop content, not on the course, which is why please, if you have any questions about the course content that is not related to this workshop today, it's better to ask these questions next week. Right? Okay, so now I opened the environment, and this environment, I have my terminal, I have my Visual Studio Code, I can do, I don't know, Python -v to find out what is the version of the Python I have. And the next thing I want to change is this thing, right? It's very long. So I want to make it PC. I want to make it shorter. So then in Linux, you do this PC1 equals, then this is the prompt you have before the command line. Right now it's shorter, right? And when I start a new terminal, it will be the same again. So I don't want to do this every time. So what I will do is I will echo that. I will add this to my bash RC. So if what I do doesn't make any sense to you, you can ask ChatGPT for some things. So these are some Linux basics, like you don't really need to understand what's happening here. But the idea here is that we start a new terminal. Right now I have this short prompt, so it doesn't take too much space, right? So for me, it's easier for demonstration purposes. And because like this line is so large, I can focus on the command here. Okay, so now I configured my bash. And here I wanna wait. This is what I want to go. I want to go back to this workshop link because this is what we are going to follow along today, right? So the environment is prepared, and now I want to start with introduction to Docker. And I see a question if you can use Cursor instead. Yes, you can use Cursor instead, but connecting to code spaces with Cursor is a little trickier. You'll need to figure out how to do this. With plain Visual Studio Code, it's a lot easier. All you need to do is installing an extension, and you'll be prompted to install this extension when you try to connect to Visual Studio, to GitHub code spaces for the first time. Okay, so now we see that we have Docker. All right, so Docker is already installed here. So what is Docker? So Docker is a way to separate what you have on your host machine. I'll maybe try to, yeah, just one second. I want to open quickly slides. So then for us, it's, for me, it's easier to explain things. So I'm going to open Google Drive. I'm going to create slides. I'm going to share my screen again. Okay, so let's say this white thing is our computer, right? So what we can have here is, and on our computer we use, so in our case, this is Codespaces, this is Ubuntu, Linux, Ubuntu, I don't know what, 24 or like what, I'm just making it up. I have no idea what kind of version of Ubuntu and if it's Ubuntu or not. You don't have to clone the repo. Yeah, you can just follow along the instructions in this repo. Where is it? Yeah, so you just follow along instructions in this repo, and instead of cloning, you create your own repository. So this is our host machine. And let's say we have an application that we want to run that requires some other version of Ubuntu. Could be Ubuntu 20.04, right? So then what we have inside Docker container is completely isolated from what we have on our host machine, right? And whatever we do here, so we can run whatever command we want, so we can just remove everything we want on that machine, and it has no effect on our host machine. So that's the main idea about Docker. Docker gives you this isolated container, isolated from the rest of the system. And whatever happens here does not affect the system, but also when we create a Docker image, I think it's better if I just show you instead of doing this from the slides. So right now, I'm going to show you a few examples, and then we'll come back to the slides. So the simplest thing you can run with Docker is this command, docker run. So let me make my screen larger. So docker run hello. So this is the first thing we run to understand if our Docker is installed correctly. So if you see something like that, it means that your Docker instance is configured correctly. So docker run should output this. So then we can also run, so this docker run hello world. Hello world oops. So this is an image, a Docker image that we run. We can use any other Docker image. Could be, let's say, Ubuntu. So when we do docker run Ubuntu, we are now downloading the image of Ubuntu, and nothing is actually happening, right? So we just did docker run, something executed, and we are again back to our computer. But we can execute it with a terminal using this IT. I think it's interactive terminal or something like this -IT tag. So when we do this, we get this prompt. So actually now we are inside this Docker container. So we are inside this thing. And whatever we do here, it's isolated from the host machine. So what we can do here is, for example, let's check if we have Python. So we don't have Python here. So what I can do is I can just do apt update. So I want to install Python. To install Python 3. So now I'm going to install Python. On the host machine, I already have Python, right? But here inside Docker, I don't have it. So I'm installing it right now. So it is asking me something, doesn't matter. Okay, so now I have actually Python 3. Then I can see its version. So this is the version of Python I have inside Docker, right? So this is the version I have inside Docker. So now when I exit it by pressing Ctrl D, I'm back to my host machine. And so this one is a completely isolated environment, right? So this, what I do here, does not affect what happens here. If I want to come back to this, I just do docker run -IT Ubuntu. But the problem is when I run this, command is not found, right? So even though we installed Docker, we installed Python previously, this right now, we are already starting from scratch. So every time we enter a Docker container, we run a Docker container, we run we create a container from a Docker image. And this image is, well, let me maybe create here, image, Docker image. So when we do Docker run, an instance of this image is created, which is a Docker container. And it has, so this Docker image contains a complete snapshot of the entire operating system. So whatever is there, it is a complete snapshot of all the things that are there. And when we do Docker run, so we use this Docker image to create a container, and this container contains exactly what is described here, right? And this is stateless, so it doesn't preserve state. Whatever we run here, and when we exit the container, and when we run the container one more time from the image, we are back to square one. We are back to whatever is described in the image. So then how do we actually install Python here, right? So that's a good question. We will talk about this later. But for now, what we can do is we can just run another Docker image. So here we will use a Docker image called Python 3.13.11. So instead of Ubuntu, we will use another Docker image. This Docker image will be Python 3.13.11. And this Docker image actually has Python, right? So it's, I don't think it's Ubuntu, it's some sort of Debian system, but it doesn't matter for us. So yeah. Also this Python package, Python image, you see, it takes a bit of time to download it. It's actually it's a big one, so we can use a smaller one by appending this lim. So here what we have, yeah, you see it's smaller, it opens faster. So what we have here is, this is the image name, and this is a tag, right? So the image name is Python, and this is a tag, and together they form like a Docker image. So when we say here, we want to use Docker image with this name, a Docker container from this image is created. And actually, what do we have now? So previously we had bash, right? We could do some things with bash, but right now what we get is a Python prompt. So here we can do some things like import os get-env, I don't know, right? So this is Python, and what if we wanted to actually execute a command here? If we wanted to have a bash session here instead of Python? So then we can overwrite the entry point. Entry point, we can say entry point is bash now, not Python. And now we are in this Docker image, but with access to bash. So now when we do ls, we can check the version of Python. So we can see that this is exactly the version of Python we wanted. If you remember, the Python version that we have in Ubuntu was different, right? So this is how we can select whatever version of Python we need. Okay, let me check if I covered everything I wanted. Yeah. That you can test later. Of course, don't do this on the computer, but the point is when you do this RMRF, and this is what I showed you. Where is it? This is what I showed you here. This does not affect the system you have. Right. And if I do something like here, echo 123 to file, so we have this file here now. I can check this file, but when I exit it and I enter again, I don't have this file, right? So we already talked about this. Docker containers are stateless, so they don't preserve state. This is not entirely true. Actually, so when we executed this command, or this command here, a version of this Docker container was saved somewhere. So potentially we can actually continue. We should not do this. It's an anti-pattern. But actually, if we wanted, we can do docker ps -a. We can see all the Docker images that we executed, all the Docker containers that are already exited. And we can resume our interaction with them. So they have all the state from there. So like when we created this file, there is a Docker container somewhere here that has this file. So we don't want to actually keep these files. So what I want to do now is I want to remove all these files. So I can do this by executing this command, docker ps aq. So this just gives me the ID of these containers. And now I can do docker rm to remove these containers. And so now I executed docker rm, and then for each of these containers, this docker rm command was executed. So now when I run docker ps -a, there is nothing. So we deleted, we cleaned our environment. Okay, so that's good. How do we preserve state? So what we can do to actually do this? Imagine we have a directory. I'll call it test. And in this directory, we have some things, right? So I think I have an example here with some things. We have 3 files. The first file has some stuff in it. The second file, file number 2, doesn't. File number 3 also doesn't have. So we have this. So what if we need to have access to these files from within our Docker container? Or we want to create a script, which I'll call script. Yeah, I know, not very creative name. And I want to use this script to actually be able to execute it from the Docker container. So first, I want to execute it from my computer. So I do this by doing this Python script. And so I want to create a script that lists the content of each file in this test directory. And that's it. So it just says, okay, there is a file number 1, and this is the content of this file. So let's create a script like that. So I'm going to use pathlib. So again, if something that I show here, you don't understand what's happening, it's okay. It's not a problem, right? So what you can do is you can take this code and ask ChatGPT to explain it. So some of you might not know Python. It's fine. So you can pick Python as you go along the course. I'll try to explain as much as I can, but yeah, so for some things, just ask ChatGPT about these things. So I'm going to use now this pathlib. This is a thing, a built-in library in Python for interacting with the file system. So then we can get whatever, like the content of the current directory using this dot. I'll call it current directory. Right, and then we can also have files. I think I have here an example. I think I'll just copy it. It's going to be a little bit easier than type in everything. So here we get, it was this, what I do here is actually the same as this. Well, I think this one is current working directory. Okay. Then we see the current file, which is script.py, its name. Then we can see all the files that are in the current directory using this iter_dir. And then we want to skip the script. So we don't want to show the content of the script. So if we see that the file name is our current file, we don't do anything. But then otherwise we show the content. Right. So now when I execute the script, we can see that there are 3 files. File 3, file 2, file 1, and only file 1 has some content. Okay, so that's our script. And now we want to execute it from inside Docker, right? So one of the options we have for that is using volumes. I'll go 1 level up. So I'm in the root directory right now. Using volumes, which means that we have a folder here. There, test. And it is available on both the host machine and on the inside the Docker container. So in Docker container, we can say whatever is in this test directory should be available on the container too. So we do this by using, what was the last Docker command we did? Okay, this one. So it is, we do this volume mapping with -v. Then we get the current, so when I execute this pwd, we get our current directory. So if I want to have the full path to my test directory, what I can do is I can execute this pwd/test, and then this gives me this, right? So what I can do now is I can get to my, this one. So then I want to map the content of this, I need absolute path test, and then here I specify, so first on the left side, I have the path to the, on the host machine. So here, the path to the host machine, and then where to which location on in the container I want to map it. So I'll map it to maybe app/test. Okay, so now I see that we have this app directory. I go there and I go to test and I see all these files, and I can execute them with Python because I have Python in this container, and I see the content of all these files, right? So this is one of the options how we can create this volume mapping, and when we have some files that we have on our host machine that we can make available on the container. Okay, so that's like Docker 101, I guess. I see the comment that RAM does not work. Okay, so we can test it. So I'm inside Docker container and I want to do RAM RF. Yeah, so it says it's dangerous. So make sure what you know what you're doing. Of course, I know what I'm doing because I'm in Docker. And now, oops, we removed everything. So ls doesn't work. Yeah, we cannot. So we broke our system. But because we're in Docker, now we go back and nothing happened, right? So it's cool. Anyways, so that's the introduction to Docker, to command line. And most of the time as a data engineer or as an engineer, you'll use Docker run command. We will use it a lot today for running Postgres, for running other things too, right? But now I want to talk about data pipelines. So we data engineers, we create data pipelines. A data pipeline is a thing that takes some input and produces some output. So for example, here today we are going to work with New York taxi dataset, right? Okay, where is it? Okay, here it is. So we have some data and we want to process this data. So we will have a pipeline that, in our case, we still have CSV files that process these CSV files and then creates, I don't know, maybe a Parquet file, maybe it puts this into a Postgres database, maybe into a data warehouse. So the idea is that a pipeline takes in some input and produces some output. So, and it takes input from some source. So in our case, source is a CSV file, and writes output to some destination. So anything, any script, anything that can do that, it can take data, a piece of data from from a source, and put it to some destination, processing it along the way. We can call it data pipeline. So in this workshop, we'll build a pipeline that we'll use Python for that. This pipeline will take the CSV file and it will put inside a Postgres database. So that's what we are going to do today, right? So that's the plan for today. But we will start with creating a simpler pipeline. So we already have this test. I'll create another directory. I'll call it pipeline. Right, and inside this pipeline, I'll have pipeline.py. So this is going to be our this is going to be our data pipeline. So this data pipeline will get some input and will produce some output, right? Okay, that's good. And yeah, there is some code. So typically these pipelines are parameterized, import. So we want to be able to provide parameters to our pipeline. So let's say we want to process a month number 12, right? So we have a whole year worth of data, and we want to process the month number 12. Okay, so then what we do is, first of all, let me hello pipeline. So I'll go to pipeline and I execute this Python pipeline, right? So then we get some output. So I want to parameterize it and I want to process it for a specific month. So then we can use command line parameters, something like pipeline 12. But oops, how do I pass this to inside the pipeline? So then we have these argv things. So I can show you arguments that we have. So when I execute it, so whatever I pass here, right, is passed to this argv. So then for us will be month number 12. And then I can say that our month, I think in this here in this document I do day, but I think month is more logical. So it will be sysargv1. So the first one is always the name of the script or the name of the thing we run, and the second is and so on are parameters. So then I expect an integer here, and then I can say month is this one. So I have a GitHub Copilot. That's why I have these suggestions. So don't let them distract you. Okay. So and then now when I run this, I have this hello pipeline, my month equals 12. So this is how we can parameterize our pipelines. What if we want to do something more fun? Let's use Pandas. Pandas is a library for data processing. This is in Python, this is the default way of processing data. Right, and then let's say we have for our month, we have some data and data frame. I was hoping Copilot would suggest something. No. Hey, come on, do something. Okay, so I'll just copy it. So then this will be our data frame. And I can show what is inside this data frame head. And now we see Pandas is actually installed on this computer. That's why when I run this, everything works. So we have a data frame with column A, 2 records here, 2 rows, column B, 2 rows. Maybe I can do something more creative, like number, I don't know, day, and number passengers. Right, so this is more interesting. And then here, what we can also do is we can create another column, which I'll call month, which will be equal to month. And when I run this, I have this data frame, right? I mean, it's not really a pipeline, but we kind of pretend that our input is this month, right? And then we are doing some data processing. And then at the end, whatever data processing we did, we want to save it to Parquet. What I also want to do is I want to install a Python extension. So do we have extensions here? Because I want to have autocomplete. So Python install in code spaces. Okay, it's installing because I want to understand what kind of methods I have here. Okay, so now hopefully it will just work. Do I need to reload or what? Okay, so now it works. Okay, so now I want to save everything to Parquet. Parquet is a binary format for data, and it's optimized compared to CSV. So we will work with both CSV and Parquet today. So now we did some processing, and I want to save data to Parquet. So now when I run this, I say, hey, you have a missing dependencies. So I cannot save to Parquet unless you install this thing. So what can I do? So now what I can do is I can just do pip install PyArrow, and it will be fine, right? But when I do this, when I do pip install PyArrow, what happens is I have my host machine, and on my host machine, I have Python, version of Python, and then I will install PyArrow there, right? And maybe I don't need it for everything. So what I want to have is I want to have an isolated environment. I'll use I'll have a different background for this environment, so it's or maybe like it's dotted. Yeah, it's dotted, and then how do I change it to? I want to change the feeling. It's here. Okay. Yeah. So this one, it's going to be a virtual environment I create for our project. Virtual environment. And Python I will have within this virtual environment is different from Python we have for Docker image. Let me put it a bit up. Oops. So what is happening? So I'll put it here. So I want to use a virtual environment such that the Python I have in this virtual environment is different from Python I have on my host machine. And this is not a complete isolation like in case of Docker containers. So I'm still running this on my Linux, on my host, but it's just the Python I have here is different from this Python, right? So this is what virtual environments are. And I want to install PyArrow here. PyArrow. So I don't want to install it here, right? And when I have multiple virtual environments, each virtual environment can have whatever dependencies it needs. And this way we isolate one project from another. So for that, I'm going to use a tool called UV. UV is, go away. So UV is a tool that can manage these virtual environments. And with UV, now I'm already in this pipeline. So what I can do is I can just do UV init, and I can specify the version of Python I want in this. So I say I want to have in this virtual environment that I have, I want to have Python 3.13. So when I do which Python, this is the system Python. So when I do Python -v, so this is the version of Python, of the Python that we have in system. So this one is Python 3.12. But when I execute the same command within my virtual environment, when I do UV run Python -v, then the Python that we use here is different. It is executed within UV, and this is what we have. We have Python 3.13.11, right? So here Python is 3.13. And when I do UV run which Python, the path is different. You see that it has created this .venv folder, and Python is actually there, right? So this is how we have this isolation. So instead of relying on Python that lives here, right? it creates its own Python here. So, and when we do Python here, uv run Python, then what we execute is actually this Python. And now I want to do uv, I want to use this uv to install this dependency. And we actually have two dependencies. And by the way, I didn't mention that when I did uv init, this file got created. It describes like our project. And now I want to do uv at pandas. That's the first dependency. So here our main host Python has pandas, but within virtual environment it does not. So we need to specify it. And then we also need PyArrow, right? How do I write it? PyArrow. So now we are installing these libraries, and you see that it added this section with dependencies. Okay. And we also need to know the code that now we actually use this Python here. So I can do this by selecting Ctrl+Shift+P and then Python select interpreter. And I can say that I can just enter the path, Docker workshop, pipeline, venv, bin, Python. Oops. Okay, so now it knows that we can see it here. It now knows that it needs to use this Python. Okay, so that's good. So now when I do uv run Python, what was that? Pipeline. Yeah, I need pipeline 12. So now it actually uses PyArrow inside our virtual environment to produce this file. And since it created this Parquet file, I want to update our git ignore. And I want to say that all Parquet files should not be committed to git. So when I save it, it should go gray. Yeah, now it's gray. So we see that we're not going to accidentally commit this code to git on this file to git. And by the way, maybe it's a good idea to actually do this, to commit things to git. So I'll just add everything to git and I'll call it git commit pipeline, maybe. Okay. So now we have our first pipeline version, right? So now we are going to put this inside Docker, right? So now we want to create this Docker image. So instead of using this Docker image that we have here, we want to create our own Docker image that has Python 3.12, 13, sorry. It has PyArrow, it has all the dependencies we need. And when we run Docker run, we actually run this script. We run this pipeline. So that's what we're going to do now. And I see a question, what are the advantages of UV over Conda Mamba? UV is extremely fast. You don't even notice how fast it installs libraries. So I was a big fan of Conda, but and only until I discovered Rust, or only until I discovered UV. UV is written in Rust, and it installs libraries super quickly, right? So this is the main advantage. It's like super fast. Okay. So we wanted to create this Docker image, right? And we do this by creating a special thing called Dockerfile. So Dockerfile describes how exactly we built the Docker container. So it has all the instructions we need in order to create the image, and from this image create a Docker container. The first line is always from. So we need to know what we base our image on, right? So Copilot recommends this one, but I want to change it to this one. So I think this one, this was the one we used, right? Then what else? What do we need? So we need to install Pandas and PyArrow. Thank you, Copilot. Then we also need to, will it now recommend to copy pipeline? copy pipeline py to this current directory. We can also specify our, yeah, thank you. So we also can specify our directory by saying workdir, and workdir could be /code, for example. So when we do copy pipeline, it actually will be copied. So let me try to build this right now. So it's not complete yet, but I want to build it so then you understand what is happening. So I do, am I in the right folder? No. So I do docker run, then -t. T is the tag I want to do. I'll call it test pandas. So test is the base image name, pandas is the tag, and this whole thing will be, this is how it will be called. And then I need to say in which directory I want to build. So I'm going to do this in my current directory. Okay, of course I need, instead of run, I use build. So right now it is running the first command. So it is installing pandas and pyarrow. After it finishes this, so we see that there are 4 steps. After it finishes this, it will execute this command and then this command. We saw that it was pretty fast, right? So now this is actually done, and what we can do is we can do docker run test pandas. Okay, nothing happens because we need to add IT, and we need to add entry point, which is bash. And also remember that I showed you that all the things that we execute, they actually stay in the system unless we explicitly delete them with -rm. So this is an important command. So if we include this command, then when we finish our Docker session, when we close our Docker container, we will not have this, how to say, dangling, or like we will not have this state saved somewhere, right? Which is good for our file system. So we don't have any things we don't need. Okay, this is how I run it. And you see that I'm in this code /code directory, because this is my working directory, right? And when I do ls, I see that pipeline is here because we copied it. And now I can just run Python pipeline. And of course, it should be Python pipeline 12. And we can see that it ran it and it created the file, right? So of course, we don't want to execute to run this container and manually execute the command we want. So what we do in this case is we redefine entry point, and entry point in our case will be Python pipeline, right? So this will be the commands that will be executed when we do docker run. So now let me build it one more time. So you see it says cached. It will not attempt to run these commands again. It will just take the thing it ran previously and it will use it. So for us, it's very good because it saves a lot of time. But this command is new. Sorry, this one is not new, but like the one with entry point. So actually, now when I do run IT rm test pandas, yeah, now it will complain that we forgot to specify the parameter because entry point is already this one. So now we can say that this is our parameter and this is executed. So now we created our data pipeline and we Dockerized it. But what about UV? So here we used UV, right, for our virtual environment, but here we did not. So I will remove this RMRF. Here we do not use UV, and actually right now our Docker image is test pandas. So how about we actually use UV here too? So then we can update our Docker image. And the first thing we will do right after this copy, right after this from, is copy. So copy we used here copy. It means copy from the host system to the Docker image. But what you can also do is you can specify this argument from. And when you do this, you copy it from a different Docker image. Right? So in this case, you take this Docker image that contains UV, right? And then you take UV from there and you put it in /bin, right? And then when you do this, UV becomes available. So now here we have UV after executing this. So we can do UV run and stuff like that. Then we don't need to install these things. We need to copy. Not requirements, but by projects, by project TOML. We also need to copy Python version. Here we have our Python version. This is something that UV created. And we also want to copy this UV log. Right. So, and then we want to copy it to the current directory. And I want to specify the current directory before we do this. So we create the current directory, and then we copy these things there, right? Let me actually comment this to see what's happening. I'm going to build it right now. So this is what happened. So we copied UV. We said that this is our working directory, and then we copied the files. So now when I execute this thing, ENTRYPOINT bash, yeah. So we have these things, right? And we also have UV. Cool. So now what I want to do is I want to run UV sync locked. So when I do this, it installs dependencies from this uv.log file. And we make sure that this way, we make sure that dependencies we install here are exactly the same dependencies as we have in our virtual environment. So in this case, the Python environment we have here will be exactly the same as the Python environment we have here. So, and this is very important for reproducibility. So yeah, let's run this. So you see that this one is synced, cached, sorry, but this one is doing right now. And did you see how fast it was? It was 4 seconds, and compared to installing it with pip install, it was faster. It was slower. So this one is faster. Okay, so now we have installed the dependencies. So now we copy pipeline, and we can just add UV run. So let me build it one more time. And when I run it, we don't need entry point anymore. 12. Okay, so now it works. I personally don't like writing UV run here. That's why what I do, I will show you. What I do is I do this. So instead of code, it's app. Or instead of app, it's code here. So this is the current directory. So this is where UV is going to install, create the virtual environment, right? So when I do this, when I add this thing to path, then I don't need to add UV. Right? So then when I execute Python, Python will come from here. So now I'll need to rebuild it. And I can execute it now. And it's working. Cool. So we created our first Dockerized data pipeline, even though it's not really doing much, right? Here, pipeline. Okay, cool. So we've done quite a lot. Oh, it's been already 1 hour. Time flies. Yeah, so test pandas is the name I gave to the container, and this is on my machine, right? If you do the same, you will not be able to find these test pandas on your computer. So what you need to do is you need to first have this Docker file, you need to build this Docker file, and only after that you can run this, right? Because when I say build test pandas, I assign it a tag, right? So this -t means take a Docker file that is inside this directory. This is the current directory, which means we are going to use this Docker file. So take this Docker file and build a Docker image from this. And whatever you build at the end called test pandas, right? So this is going to be our image that we have here. And when we create a Docker container from this image, when we do Docker run, then all these instructions are already in the image, right? So that's why the state of this container is exactly this. So it has all the dependencies we need. It has the pipeline of the right version that we have. It has the code, and it can just run this thing. And we also notice that it produces a file. We don't do anything with this file. So this file stays in Docker container. So if I remove this thing now and run it again, this Parquet file does not appear because it stays in inside Docker image, inside Docker container. Right, and then it's up to us to decide what we do. We can maybe decide to upload this Parquet file to S3 or Google Cloud Storage or whatever, right? We can do something with this. Okay. So now I want to show you another example of using Docker run, and this is going to be very useful. There, we are going to use Docker to run Postgres, and which is very cool. Before I know how to use Docker, before I knew how to use Docker, and I wanted to use a database, be it MySQL or Postgres, I needed to figure out how to install it. And if you use Windows, like for Linux, it's usually more or less straightforward, but for Windows, usually it was a trouble, always, and not super straightforward. But also, even if you have Linux, you would be installing it on your host machine, right? And let's say you want to just experiment with Postgres, or maybe for this application that you're developing, you need a specific version of Postgres, right? And then maybe you have two applications on your computer, and one user needs one Postgres and another needs another Postgres, right? So this is why Docker is useful, because you can just run whatever version of Postgres this particular application needs. And when you are done working, you just stop the container and you can start another container for another application. So I'm going to now run this command. And actually what I should do here is I should also add --rm. Can I edit this quickly? Because I don't want to keep these unused Docker images on my system. Yeah, --rm. And we are going to run Postgres number, the version of Postgres 18. So this is the command we are going to run. I am first going to paste it here, so then we can take a look at this. So what is happening here? So let me take my annotation. So then we have this this block with this -e thing. So here we are passing environment variables. So environment variables are ways to configure your Docker application. So we could have also passed environment variables to our pipeline, right? So these are just ways to configure your application. In case of Docker, in case of Postgres, we are actually configuring Postgres. We say that we want to create a user that is called root. And the password of this user is going to be also root. And the database we're going to create is going to be called ny_taxi. So this is the way how we configure our application, and this is different for every container. So in this particular container, these are the potential variables we can use. Then another thing is this -v. We already talked about this, but in our case, if you remember, I'll stop it for a second. So when we used our volume mapping. What we did was we used this, PWD. So we had absolute path. Here we don't have any name, right? So here what we have is just, we don't have any slashes. Sorry, we just have a name. So this Docker volume is going to be an internal volume to Docker, so we will not be able to see what is happening inside, which is good, like we will not be able to interfere with the content of these files. They are internal to Postgres. But this line is actually quite important because with it, we can preserve our data. So we can put whatever data we want to our Postgres, and next time we run it, the data will still be there. And then this part here, it says that whatever application is running on this container, I'll show you here. So maybe there is some application that is running here, right? So we have, so it could be Postgres, it could be Python, it could be whatever. And this application is waiting for requests on ports, on port, in our case is 53, so this port, right? So we have this application with this port inside, but what we want to do is we want to make it available for outside of the container. So when I run something from the terminal, in the terminal on my host machine, I still want to be able, I want to be able to access this, right? And then I do this by volume mapping, or by, sorry, not volume mapping, but port mapping. So, but the concept is the same. Here we have volume mapping, we map something, and the error should be the other way around. So the concept is the same as with volume mapping. So we have a folder on our host machine, and we map it to the container, right? And here it's the same. We have a port on our host machine, and we map it to the port on the container. If there is an application that is running on this port, then when we send a request to localhost, so this will be our local host. So when we send a request to localhost, now we actually send a request to whatever is running inside. Oops. Whatever is running inside the container, right? So the syntax here is the port on the host machine, and the port on the container. So now let's run it. Oh, I already have it here. And we are downloading now the image of Postgres. And we see that the database system is ready to accept connections. That's amazing. I'm going to create a new terminal. And in new terminal, I want to access this instance of Postgres that is running. So what I want to do for that, I want to use a tool called PG-CLI, which stands for Postgres CLI, I guess. And this is a Python tool. So I'm going to install it using UV add. And then I'm going to add this flag --dev. And the reason, okay, I need to go to pipeline. And the reason I do this is because when I do this, we have these dependencies and we have these dev dependencies. So when I do this here in my Docker container, when I do UV sync locked, I only synchronize, I only install my main dependencies. I don't install dev dependencies. So dev dependencies are dependencies you only need for development. So in my case, I need PG-CLI to be able to interact with my development environment. And I don't need this in production. In production, I'll use something else. That's why I add this library as a dev dependency. But now what I can do is I can run PG-CLI. And then I actually have this, I can execute this command, right? Okay, it's complaining right now because we need to also to tell it how exactly it should be able to connect to Postgres. And I have this somewhere here. I'm just going to copy paste this, right? So we need to say that the host is localhost, the port is this. And because we did this volume mapping, so PG-CLI is running inside our virtual environment. pgcli, but it is running on our host machine, even though it's in a virtual environment, right? That's why when we say pgcli host localhost, let me put a little bit down, no, maybe up, localhost port, this one, it can connect to this one. So it connects to localhost, but then it in turn is forwarded to our Docker container. And then we need to specify the username and then the database name. And the next thing, it will ask us the password. And the password is, in our case, root, because this is what we configured in our, here. It's root. Okay, so now we are inside. So I can see what kind of tables we have. We don't have any tables because we just created it. And actually, let's create some data. I'm going to create a table. So a table that is called test, and it has 2 columns, ID and name, right? And then I'm going to insert some data here. It's going to be 1 and hello Docker. And now when I do select star from test, I see this record and I also see this table. Is it wrong? Yeah, I see this table. And so now we can interact with our Postgres that is running here, right? And then when I stop it, right now I think I will not be able to do anything. Can I do DT? Yeah, it says here nothing is running. But when I run it again, I should still have all the data that we. Okay, so it's reconnected and the data is there. Cool. Okay, so what do we do next? So now we have Postgres, and we have the ingestion script that we have in our already in the container. And what I want to do with this script is I want to turn this script into. So what I want to do with this script is I want to get the CSV data with the New York taxi trips dataset, and I want to put this inside our Postgres. So that's what we are going to do right now. And for that, I want to have an interactive environment. So I'm going to close pgcli, sorry. And I want to install another library, which is called Jupyter. It's again going to be a dev dependency. And Jupyter is interactive environment for Python. Jupyter notebook. So that's the command we need to use. And what is happening right now, it's starting a Jupyter notebook. Okay. And right now, you see that I have this one in ports, which means that it automatically detected that there is something on this port, 888, and it automatically forwarded it to port 88889, right? Because I already have something on port 88888, so then it forwarded it to the next available port. If you don't have this for some reasons, so then you just click add port and you put the port 888 and that's it. So then it will, if it doesn't detect it automatically, you just tell it. And what I can do now is I can open it. Yeah, and then I will have this screen. And for this screen, I need a token. So token we have here. And so I'm going to just copy this token and put it here. Yes, I'm running this command in the same place where I have Docker. So this is inside this pipeline folder. So, and this is important because we installed Jupyter as a dependency here in this project, right? I want to use dark theme, and I want to create a notebook, new notebook. I will call it notebook. And I also want to remove the header because it takes a lot of space. And here, when I do import pandas SPD, I have pandas because I think this is how I see. So because this pandas is coming from this virtual environment, right? And then it has PyArrow. It has all the dependencies we installed in our environment. So this is running. This Jupyter is running in this virtual environment. Okay. So what we want to do here? So I want to use pandas to read a CSV file, and this CSV file is actually so this CSV file is actually something remote. Where is it? So we want to read this taxi trip dataset. And right now, this taxi trip dataset, if we look at, say, this one, we can see that this is in Parquet. When we started the course 4 years ago, or when was it? We actually, the data there was in CSV. So that's why we use CSV. And then I think right after the course finished, they replaced everything to Parquet, right? But I like the idea of processing CSV because it's one of the things we can do. So we can take the CSV files, we can turn them into Parquet, so we have a little bit more to do, a little bit more work to do, as compared to just taking the Parquet that is already prepared, right? So where is this workshop? This is the workshop, right? So we created a copy of this data. Well, it's not all the data, it's up to a certain point, up to 2021, right? And it has data in CSV, right? So this is what we are going to use to work with this data. So let's say for yellow, taxi data, yeah, we just put this on GitHub. And this is what we are going to do. It's in CSV and it's gzipped, so it's compressed. So let's use this. So I'm going to read this data set from here, right? So I'm going to copy this. This is pretty arbitrary, so you can pick any you want. And with pandas, what you can do is you can just directly give the URL, right? So you don't need to do anything. So I'll make the code a little nicer. I'll create a variable called URL. And then I'll also split it into prefix. So this long thing is prefix. So then what we'll have here is prefix /file, right? And this is going to be our URL, which are we going to use here. Okay, so it is complaining about the columns that have mixed types. We will address this later, but for now, let's just ignore it. And we can take a look at the content. So this is what we have. So we have some data. If you're interested in what this data is, they have this yellow trips data dictionary that is describing exactly what is happening, right? So vendor ID is 1 means creative mobile technologies, 2 curb mobility, and so on, right? So then we understand what is happening here, right? And then we have like pickup date time, drop off date time, how many passengers are there, the distance, the location where the passengers were picked up, dropped off, how much they paid, how much they tipped, and things like that, right? Oops. What is happening? Okay, so that's the data. And we want to put this data inside Postgres, right? That's our goal. And actually, this is not the smallest data set. So it has more than 1,300,000 records, right? So this is not the smallest data set. But first, let's address this this problem. So this problem is because we need to set up, like Pandas cannot figure out automatically what kind of type is there. The type means type. So it cannot figure out what kind of type is there, because we see that for vendor ID, even though it should be, well, let me select in this. So even though we know that it should be an integer, it's actually detects it as float, because for some rows, the data is missing, and when the data is missing, what Pandas is doing, it automatically treats it as float. But this is not what we want to do, because we saw the data dictionary. In the data dictionary, it's clearly an integer, it's not a float. So that's why it's complaining about these things, right? Another thing here is this pickup date time. Right, so this is object. Here it means string, but this is actually datetime format. So what we can say, we can tell Pandas, hey, this is actually datetime, please parse it, right? So we can specify the types, and this is actually pretty helpful. Typically, when you work with data, especially with CSV, CSV is kind of schema-less. So Parquet already contains schema inside the Parquet files. So in Parquet files, you know the types. But in case of CSV, you don't know the types. So Pandas is trying to infer this somehow. What kind of name is that, Pandas? So Pandas is or are? Anyways, so Pandas is trying to infer the type, but it cannot. So we need to help it a little. And I already did this, and we will also see this in our Spark module. It's module number 5, batch processing. In Spark, it's actually very important to set up types. So here we set up the types. We say vendor ID is actually an integer, it's not a float. And you can go through this type by type and figure out what is that. And for this pickup date time and drop off date time, you can say that this is actually a date. And when I copy this thing, so let me use this URL. So then when I do this, so first of all, it doesn't complain anymore. Well, I didn't need this. So this n rows is we only want to read the first 100 rows. And now we are going to read the entire thing. And it's taking a little bit more time because it's trying to parse all these things, right? And when we do df hat, now this vendor ID, we can see that this is not a float anymore. And this is supposed to be a date time. We can check that. Yeah, it's date time. Okay, so we did some parsing. We don't have this warning anymore. Cool, right? So here, for cases when we don't have any data, in case of integers, we have this NA value. Okay. So now we have the data that is already in the format we want, but we want to insert this. I think it's actually going to take more than 7 minutes because the workshop is supposed to finish in 7 minutes, but I think I'll need like half an hour more. So yeah, I hope you're enjoying this. But of course, feel free to stop watching it now and come back later. Okay, so now what we want to do is we want to put this inside our Postgres. right? So first of all, what we want to do is we need to install a special library. So this is called SQL Alchemy. And I'm going to now, so this is what Pandas is using to interacting with different databases. So using Pandas, you can insert data to MySQL, to Postgres, to Oracle, whatever, because it uses this SQL Alchemy library. So let's install it. So I'm going to install it from here, uv add SQL Alchemy. So when I do this, it's the same as executing it in terminal, right? So then when I check my PyProject.toml, I can see that SQL Alchemy is added. Okay, and I can actually remove this thing from here. And yeah, so now I want to specify how exactly I'm going to connect to the database. So I need to say, what? Okay, we'll address this later. So I need to say that, okay, this is a PostgreSQL. The user is root, the password is root, it's running on localhost, the port is this one, and the database is this one, right? And when I do this, it complains that there is no module named psychopg2, so I need to install it, and I do uv add, oops, psychopg2, and then I need to add -binary, because otherwise it will try to compile this from the sources, and it's taken forever, so just install a binary version. And now when I execute this, this one is working. So now we can actually use this df to SQL to insert things into the database. First, I want to show you the schema. So this is what it's going to create. So this pd.io SQL get schema. This is the schema that is going to create inside for our database, right? So the table will be called this. This will be the columns. And when we do df to SQL, and here we need to specify name and connection. So what it's going to do is, if this database does not exist, it will create it and start inserting data there, right? What I also want to do is I want to just create this schema. So I just want to execute this thing in our database. So I don't want to insert any data yet. I just want to create the schema, right? And what I do for that is I do this df hat 0. So when I do df hat 0, I can show you, I get an empty data frame, but I know all the information about the types because they are here. So what essentially happens when I do this to SQL here is that it creates this, but it does not insert any data, right? So that's what I want to do now. And I also need this if exist replace, right? So if the table with this name already exists, then we're just going to drop it and create a new one. Okay, so we just executed it. And now, do I have my PG CLI running? I don't think so. So let me quickly find it. PG CLI, because I want to quickly check. I need to be here. So when I do DT, we see that this database is created. Okay. So now this database is created, and we want to start inserting data to this database. The thing is, we cannot just take this entire data set and insert it at once. So first of all, it will take a lot of time. We will not know what is the current progress, the current state, where it is, and like we will not be sure, is it doing something, is it broken? So what we typically do is we split it into equal chunks of equal size, and we put these chunks one by one, right? And instead of loading this entire thing into memory, what we can do is we can read chunk by chunk. Let's say our chunk is going to be 100,000 records. So then we read the first 100,000 records, we insert it into the database. Then we read the second, and so on, right? So that's what we are going to do. And for that, so here when we read our data, we need to. So we're going to create an iterator, and we just add iterator true. And is it batch size? I don't remember. Chunk size. Chunk size 100,000, right? So this way, when we do this, we get an iterator. So this is not a data frame yet, but we can get each of these data frames by using this next, right? So this one is the first one, and then this one is the next one, right? And then iterating one by one, we can iterate over all the files, right? And typically, the way we do it is we don't use this next. We do, we can just use a for loop for df in df iter, and let's say we print the number of records there. So now I'm not inserting it into a database, of course. I'm just, iterating over it. But what I can do is I can execute this. And then if exists, what are the parameters? What are the options there? Yeah, I cannot see, but I'll just then append. Okay. So if I call chunk, so what I will do now is we already have created the database, right, on the table. So now I'm just going to iterate over each of these chunks, and I'm going to insert these chunks in the database. And to see the progress, I'm going to use a library called tqdm. So from tqdm auto, import tqdm. So I'm going to wrap this iterator in tqdm, so then I can see the progress. So we can see that something is happening. And it takes, I think, like around 7 seconds for each chunk, or 8 seconds, yeah. So you see the first chunk is already in. So now it will insert the second one, and so on. But what we can do already is I can select from, or well, let's maybe do this select count from yellow taxi data. Okay, so we see it's already 300,000. Now it's 400. And now we just need to let it finish. Okay, how is everyone doing? Still here? So I think we don't have a lot of, like, maybe 2 units left. So now we ingested this data. Now I want to create, I think it's 3. So now I want to translate this Jupyter notebook, which I want to rename. Yeah, it's notebook. It still shows untitled here. So I want to turn this into a script, into a Python script. Then I'm going to talk about pgadmin, which is an interface to Postgres, which we can use instead of this pgcli. And then finally, I'm going to talk about Docker Compose, which is a way to put all these Docker containers together. Okay. So I'll let it finish. But here, what I will do now is I will execute this command uv run Jupyter nb convert to script notebook notebook IPython notebook. So what is this command is doing? It's taking the notebook here and it's creating this notebook py file, right? So this is our notebook, but right now it is a script. And now I'm going to rename it to, should I call it pipeline? I think I have a different name here, so maybe I'll just stick to the name that we have. Ingest data. Okay, so I'm going to use this. Instead of notebook, it's going to be ingest data. So now I'm going to clean this and turn this into a proper script. So here we have a few parameters. So the first parameter we have is year, which is 2021. Month is 1. Right, so then here we can already exactly, hey, where did you go? Okay, yeah, thank you. So P is of course not needed. Yeah, so this way we can parameterize it. We can run the script for any year and month. Of course, only for those that are here in our data set, right? Then what else we can parameterize? We can also have PG user, PG password, PG host, PG database or DB. So in this case, it will be root localhost. And here now we can replace this with this line, right? So we parameterize it. Probably we also need PG port. This one, and of course we replace it here with a port. I'll move all the imports to the top. This parameter also to the top. So I'll move this down. And here I'll call this thing, let's say run. So all these parameters I'll put there. Maybe another parameter that we are interested in is chunk size. So this could be another parameter. Okay, TQDM goes here. And we need to do this thing, right? So here we do this, but we don't execute this thing. So what I can do is maybe have a variable I call first true. If first do this to SQL, let me format it a little. So this one will be triggered only for the first one. Okay, and this name, I think we can also parameterize it as table name. Yeah. So let me actually check how I call it here. So I want to make sure that target table. So let me call it target table too. So then it's not very different from what we have here. And then target table. Target table. Okay. And this thing goes here. Okay. And now I can add something like if name equals main, do run. Okay, what is happening? Yeah, cool. So this is now our ingestion script. So this is our pipeline. I'll just call it ingest data. I think it should work. So I'm going to test it by doing uv run python ingest data. Ingest data. Okay, it seems to be doing something. So I think if I do not have my PG. Okay, but yeah, we can see. So what is happening right now? It dropped the database. It dropped the table, and yeah, it's inserting it one more time. Okay, we don't need to finish it. Yeah, so this is our script. We can actually now, so before we Dockerize it, I want to, so here, all these parameters, so I want to make it configurable. So what I'm going to do, so first I'll commit this to Git. So git add, git commit, I'll call it pipeline, call it working. Yes, not the most creative message. And right now I'm going to change it. So I want to make it configurable through command line interface. So when I do this, I want to say PG, I don't know, I want to say year 2022, right? So I want to configure it through the command line. And for that, right now I'm going to cheat a little. I'm going to use Copilot. Oops, where's my Copilot? Yes, I'm going to use Copilot. And I'm going to ask it to use Click. Click is a library for creating command line interface. I will ask it to create me the command line interface for this. Use Click to create click parameters for this script. Params are this. And now GitHub Copilot will rewrite the code. So it will check if Click is installed. It will install Click. Cool. But if you don't have GitHub Copilot, I already have the result here, right? So you import Click, you add this, and you specify all these parameters as the parameters to the function. And then you will see the result. So these parameters become the parameters, the command line interface parameters. Okay, so it added import Click, then it added these options, and then it added them as parameters. And here what we do is just this main, right? And now it also gave me the commands. I can actually do, where is it? Yeah. Sorry, I have too many things open. I'll close this one. Yeah, help. And now we can see what kind of parameters we have. So this Click is very convenient when you want to create command line interfaces. And I already have this command here that hopefully should just work if I copy paste it. And maybe what I will do is I will change this. I will put this inside 2022-1, right? So this will be the new target table. Oops. Terminal, I need terminal. Oops. Actually, please execute this one. Okay, now it's executing. Do we need to drop tables before executions? No. So we don't here in our script this thing to SQL replace, it automatically drops it, right? So up to you to decide how you want to handle it. Maybe you want to signal it, hey, it already exists. Don't do this, but in our case, replace means drop if it exists and create a new one, right? Okay, and the question is, there was a question, what is this line doing? So I can run my Copilot in ask mode. What is this doing? Well, actually, this is a way to run the script. So it will say, this code checks the script is being run directly. So when I run it from command line, this executes. But when I do import ingest data, this is not execute. This does not execute. Yeah. So I'll just ask ChatGPT. It will give you probably a similar answer. Okay. So it is the size of this data set is 1,600,000, I think. Something like that. Okay, what's next? Next, we can verify that these things are there. Okay, let's do that. Export is root. DT. This is this new data set. Select 2021 1. Okay, so it's still inserting it. Okay, so now what I want to do is I want to actually turn this into a pipeline, into a Dockerized pipeline. So right now we have this pipeline that is taking data from the CC file and putting it into Postgres. But now I want to modify our script. And instead of copying pipeline, I want to copy ingest data. Do I need to do anything else? I think because all the dependencies that we have, they are inside this pipe project toml. So it means we don't need to do anything, right? So it will automatically install everything we need. So we can just build it. So I think I'm skipping a session. I'll come back to this section section afterwards. But what I want is this line. So I just want to make sure I use the same tag as before. So yeah, I want to. So I cd I change the directory to this pipeline and execute it there. So it's the same thing as we did before. I just changed the file I copy, and that's it, right? So we don't need anything else. All the dependencies are inside this by project toml, so they are executed. And the way we run it is like we run here. Right? I'm going to copy this command. Let me actually stop it. Oh, it's done. Okay. So I'm going to use, instead of this, what I'll do is I'll do docker run. Yes, it -- rem. So then we will need to have a few things, like where we are going to insert it. I'm sorry, like the name. So this is here. I'm sorry, I'm very confused with all these terminals. Should I close them maybe? So this one I don't need anymore. Okay. So what I'm doing here is we have this command, right? I'm going to put it here. So this is what we used to execute it from our virtual environment, and this is how we are putting data inside our Postgres. So what I want to have now is I want to have, let me create another slide. So we have our Postgres. I'll call it Postgres 18, right? And then I want to create another container, which will be our ingest script. How do I call it? Alexey ingest. So this one, right? And then what this container is doing, it has all the dependencies for our script, for our ingestion pipeline, right? So what I want to do is I want to execute it such that so that we have this pipeline here. How do we call it? Ingest data, right? Ingest data. So this ingest data, what it is doing, it's getting some data from from the internet, and it's putting this data to Postgres. Right, so that's what we want to do now. Okay, so let's do that. And we already know how to run it from our host. This is how they do this. And when we do it inside Docker, it's very similar. Instead, this command, we put all these arguments here. Right, and now let me try to run it. Okay, and what will happen now? It says there is nothing running on localhost, but we know that actually something is running on localhost. And the problem is that localhost inside the container is not the same as localhost inside this host, right? So for us, for the host, localhost is this one, but for inside the container, localhost is this one. So what it's trying to do now is it's trying to, so I think I should take this one. So what it's trying to do is instead of connecting to this one through localhost, so essentially what we're trying to do is this one. So we're trying to do this one, or we think we're trying to do this one, right? We hope we are doing this, but instead of that, we are actually doing this, right? And inside the container, inside this Docker container, so this is localhost, there is nothing running on this container, right? So that's why we need to find a way to connect to this. And the way we do this is by creating a network. So we do Docker network. So we can Docker network create, and we can call it PG network. I think this is how I called it. Yes, PG network. And when we do this, okay, the network is created. Then what we can do is I can say that I want to run this thing inside the network, inside of this specific network. So when I run Postgres, I want to say that network for this container is this one, and network for this container is the same one, right? And when we do this, what happens is these two containers, they become a part of the same network. Let me move them down a little. So this will be our network. Yeah, I'll make it transparent. Okay, so this is our network, which I call PG network. PG network. So why do we care about these networks? So things within the same network can see each other. So when I give this thing a name, so I can call it, this computer I can call, let me check how I call it. Just 1 second. I call it PG database, right? So this one is PG database. So this is the name of this container on the network. And the name of this container could be ingest or whatever, right? So when we do this, I can say instead of localhost, I can say I want you to connect to PG database. So instead of localhost, I say PG database, and I want to use this port. And what will happen? It will know that instead of trying to use localhost, it will need to use this one. So it will not try to use the port of the host machine, right? It will try to use the port on the container directly, right? So this is what happens when we run these things within the same network, so they can see each other and then they can also access ports of each other. And I'm going to now, we also need a name. So this name. So this is how they can see each other. But this one, we don't really care about the name. It's not that important. It doesn't need to be discovered by other things in the network. Okay, so now I'm going to stop this and I'm going to execute it one more time. But this time I'm going to execute it on the network. And this one here, I'm going to also execute also on the network. And also now I need to change the host. So the host becomes this PG database, not localhost anymore. So now when I execute it, now hopefully it should work. Well, I think it is working, right? So it hasn't complained yet. Okay, so it is working. And the next thing I want to do, instead of using PG CLI, I want to use a proper UI for this. And for Postgres, this is called pgadmin. So I have this command here for pgadmin. Then I'm just going to copy paste. It's very similar, right? So we have some environment variables, we have some volume mapping, we also have port mapping, and this is the name of the thing, of the image, and this is the name of the container, right? So what we will have is something like this. Okay, I think I don't have enough space. So it will also run on the same network. It will be pgadmin. And we'll call it pgadmin, right? So it will run on the same network. And here the port will be inside it's 80. But outside it will be a different one. Outside it will be this one. Right, and then, oops, we'll have this mapping here. Okay, for this one, I think I should move it. Okay, so now we were able to fit everything. Yeah, so that's what we're going to do. And then inside this pgadmin, inside pgadmin, we will try to connect to this thing too, right? So because we want to we want to access the data there. So that's the plan. And this is the command we need to execute. And I'm going to execute it here. So now when it starts, okay, it's extracting. So I think it is working. Now import. Yeah, I don't see it in ports actually. Yeah, maybe we just need to wait a little. It's configuring, so let's wait. Okay, I think this one, when we see this one, it says listening at, and it means it's working. And so it was 8085, so it didn't notice it. So I'll just do 8085. Okay, so then we have it. I'm going to copy the link. I'm going to copy it to this. Okay. Did it copy? I'll close these things. So what is our port? I think I need to use this thing, right? So the port, sorry, I mean email. And this is the email. Oh. And this is the password. So I'm going to just close all these things. We don't need them. And now we need to create a new server. I'll call it PG. And in connections, the name will be, just a second, I'll check. The name will be, hostname is this one. Username root. Password root. Save. Okay, it whatever. So it didn't complain. It means that it was able to connect, which is good. So now we go to servers, PG, NYDAXI. This is the database we created. And then we have schemas, public, tables, and we have our tables. So I'm trying to do right click, and for some reasons I cannot do this. Maybe I can do it here. Oh, okay. So I was hoping to do right click, but for some reasons my right click doesn't work. Maybe I do it here. Okay, anyways, I can click it here. And what I want to do now is select count one from, and then here, what we can do is just drag and drop from here. So let's execute it. Okay, or select. I'm trying to do a star, a limit 10. Cool. So it works, but now instead of using PG-CLI, we can use the proper interface. So let's see what is happening right now. So this one, I think the notebook we can close. We don't need this notebook anymore. So I'm going to close the terminal. So here we run our ingestion from inside Docker. Cool. Then in this tab we have Postgres running inside Docker, and in this tab we have pgadmin running. So I'm going to stop both right now. And what I'm going to do now is I'm going to, so first let me take the command I used for this. So what I want to do now is I want to run both of them at the same time without using without using Docker. I want to use Docker Compose. So I need to create a file, Docker Compose YAML. And this file will describe everything, all the Docker images we need to run, all the Docker containers we need to run. So we will have a PG database container with this, and we will have also a PG admin container with all these configurations. And by default, everything you run within one Docker Composer file is run within the same network. So I'm going to do a little bit of magic again. I'm going to use ChatGPT. I'm going to ask it to turn this into a Docker Compose file. Right? Or you can also look at the result here. So there is already a result, but I think it's less, it's more boring, and this one is more entertaining to see how ChatGPT is doing this. So this is what it did. So it created volumes, it created network. Okay, so I'll edit this a bit. So we have this Docker Compose. So network we don't need, because everything that we run inside Docker Compose is on the same network. And they are, so when we say PG database, this is the name. So here, this will be PG database, and this is going to be PG admin here, right? So we have all the environment variables, all the volumes. The volumes we also declare here, and version we also don't need. Okay, that's our Docker Compose. And what we can do now is, maybe I should start a fresh terminal session. What's this one? So what I can do now is I just do Docker Compose up. And yes, I need to be in the folder. The container PG admin is already in use. So something is running. I can check what is running. And I can kill these things. Docker rm. Okay, so let me. And I think another issue is we have this container name, right? So we don't need to specify it. So then Docker Compose can actually select whatever name is good. Docker Compose up. And now we can see that, let me make it full screen. So when we did Docker Compose up, it created this container and this container, right? And then, yeah, we see some logs from PG database. We see some logs from PG admin. I think it's still starting. But when we do this, we kind of recreate this from scratch. So we don't have that volume anymore, this volume mapping. So we have like fresh instance, if you will, right? So when I go to, we have this port here still, right? So when I go here and this is my email, this is my password. So now I want to create register server PG. So you see, like we don't have that server anymore. So we need to specify everything again, because we created it inside Docker Compose. So next time we do Docker Compose up, all the data will be there. Username, root, password, root. Okay, save. And now I'm going to databases, NY taxi, schema, public, tables, query tool. So all these things we don't really need. And then, well, actually here, I don't think we will have anything. So if I do DT, there is nothing. Can I not do it here? Okay. That's how we should do it, right? No? Anyways, so like we can see that we don't have any tables here. Right? So it means that the database is empty. So we need to run the ingestion script again. And the way we do it is, let me do Docker network ls. So we see all the networks we have. And this one that we just created is called pipeline default. So it's called pipeline default because this is how networks are usually named inside Docker Compose. The folder name _ default, because we didn't specify here any network. That's why it uses the default one. So what we can do now is we can run this script for ingesting data inside this pipeline default network. And I'm going to run it right now. And well, I think it's a little bit corrupted, but like the comment that is executed is correct. So it's just corrupted on the terminal when I copy paste it. But I can see the data is already being inserted. So now, can I refresh it? Maybe I do this. Yeah, we see that there's this yellow taxi. So I can do select count 1 from this. And since it's been inserted, we can see that it's not full yet. Okay, this is actually what I wanted to show for this session. It took 40 minutes longer, but yeah, I hope you found it useful. So what we did here is going to completely replace the module that we have on Docker. And so here you have an end-to-end working solution that is working on code spaces. If you try to do this, outside of code spaces, you might run into problems. And usually in these cases, I recommend checking with ChatGPT. So ChatGPT will help. So for example, if you're running on Windows, command lines that you have here might not work. So you will need to translate it to PowerShell, and you can ask ChatGPT to do that. It's very helpful. I see there are a few questions. I'll answer these questions and then we will stop. So is this the methodology followed in many industries these days? Yeah, like you have to know Docker. You have to be able to use Docker. Even if you're not working as a data engineer, if you work as a data scientist, as machine learning engineer, as software engineer in general, you have to be able to use Docker. Does Docker Compose YAML make the Dockerfile redundant? No. So Docker Compose usually describes the external dependencies you have, but you can also use it to describe your own service. So in this case, we did not. Let me share my screen. So in this case, we actually did not include it here. So we only have these dependencies. But if we wanted to include the ingestion script here, we can also do this, right? And then in the Docker Compose file, you can refer to Dockerfile. So it does not make it redundant. In this case, we use both, right? So we use Docker Compose to start all the dependencies, and then separately we run this thing. So here we describe what exactly we need for our own ingestion script. It looks like in production environment, we can leverage the use of CI/CD pipeline to deploy containers within Kubernetes. Yeah, you can do this. So once you have a container, once you have a Docker image, right, and then you can use this Docker image to run your container anywhere. So you can run it on your local host, but then you can also run it on Kubernetes, on anywhere where you can run containers. And this is pretty much everything these days. So this is very widespread technology. You can run containers for AWS Lambda. You can run containers for Google Cloud Run. There are so many things where you can run containers. So it's the standard these days. like this containers. And we have Kubernetes it's called container management system. So it can manage containers. CI/CD too, yeah. So if you use something like GitHub Actions, it actually runs within a Docker container. But it's a little bit more complicated when it comes to CI/CD. Yeah. Anyways, I'm a bit tired by now. Well, I hope it was very helpful. So, as I said, this becomes a part of the module, and then check the next week. We'll have a session for questions, and then the course is starting on January 12th. You will find all the links on our website, DataTalksClub. Also, there is a webinar next week. I shared the link already. So check it out too on our website. There I'll show how to build a deep research agent, and there the focus will be also on creating data pipelines. Okay, that's it for now. Have a great day, everyone, and see you soon on the course.